This is Jose Porras. In this video, I'm going to be completing a circuit utilizing an LDR, a light dependent resistor. This is a 1 kilo ohm resistor, and this is an LED bulb. It doesn't matter which color you want to choose. Here I'm using a red one. I have these jumper wires, and on this microcontroller board, I have these slots that I'll be using. It's the 5-volt slot and the ground slot. Also, this is a USB that'll be connecting the microcontroller to my computer that I'll be using as a power source. So these components, the reason I have them already on here, and on one end I have the LED bulb, and on the opposite end I have the LDR. So what I'll be using, since this is a light dependent resistor, it is very sensitive to light, to its surroundings. So I'm going to be flashing a light when I complete the diagram, of course, to see how it's going to be affecting my LED bulb. So as I mentioned, I have this 5-volt slot connected on one end with the red cable, and then of course the ground one with the blue one. On the breadboard, we have these two lines. This is going to be my positive and my ground. Now let me connect on one end. The 5-volt is going to be connected to my red line, the positive line. And the blue one, the one that's connected to the ground on my microcontroller, will be connecting to the blue wire, the blue line on the breadboard. Now with the LED bulb, it has a longer leg, which is going to be the positive, and the shorter leg is the negative. So I'm going to be using a shorter wire that's going to be connecting on one end to the ground line, and on the same column, I hope you can see, we have the jumper wire installed on the same line or the same column as the shorter end of the LED line or leg. I'm gonna use this red one connecting the positive leg. So again, on one end on the same column, and on the other end I'm connecting on the same column of my 1 kilo ohm resistor. So here I have the other end connected to the positive line. So this, as you can see, is already running in some way. Now I want to be connecting the last wire on the same column of this LDR. I have one end connected to the negative line, and on the other end to the breadboard, I'm connecting the jumper wire cable all the way to my resistor, my 1 kilo ohm resistor. Now let me connect, or let me give this circuit some power. So here I have my computer. I'm connecting this to the microcontroller. So the red LED bulb is now activated. It's shining. Now what I want to see is if this LDR will be affecting how the current is running through my circuit. So of course the current is running through the LED bulb right now. That is why it is activated. But what happens if I grab a flashlight? I have this flashlight, and I'm gonna shine it on the LDR. Do you see how this is affecting my bulb? So when I put some light on the LDR, you can see that my LED bulb is no longer lit. When I take it off, it's activated once again. So what's going on here is that the current is now flowing through the LDR. The reason being is when I shine the light onto the LDR, the resistance becomes much lower, meaning that the current flowing from my power source is now going through my LDR and not through my LED bulb. That's why it's not being lit right now. But when I take it off, then my current's going to be flowing through my LED bulb. So here, I prepared in advance. This is my circuit diagram. The power source is running through the 1 kilo ohm resistor. Now, initially, we have it shining the LED, or the current is going to the LED bulb, and on this end is my LDR. Of course, this is ground. But when I shine light on the LDR, then the resistance becomes very low, and so the current is going to be wanting to flow through the LDR instead of the LED bulb. So yeah, that's how to utilize the LDR in a circuit. Thanks.